answers, all right? Absalom, go ahead.
Evaluating a given polynomial px at some value x equal a actually gives a remainder of px divided by
X minus A. Thank you, all right? So with that being said, let's use this remainder theorem to answer, let's see in here, number 6 or number 7. Let's try it out in here. Mackenzie, choose a number. 7, right? And let's read the instruction in here. Go ahead.
The following exercises use the remainder theorem to find the remainder.
Thank you, right? It's kind of redundant, right? Use the remainder theorem to find the remainder, right? But actually, it's what we're gonna do, okay? And McKinsey, you said number? 7, right? So it says in number 7 in here, 3x cubed minus 2x squared plus x minus 4. That basically is our p of x, right? That's our given polynomial px, right? Now you want to divide this one by what? X plus 3, right? But you just want the what? Remainder, right? What is remainder? So what did we say in there? Whatever your divisor is, you evaluate the polynomial by what? Sign change it. Okay? So again, whatever your divisor is, what do you do with this? Sign change and evaluate px. Okay, so that's basically what we're just gonna do in here, right? So going back in here, for number 7, you evaluate p at what? Negative 3. Okay, so what's that gonna be? 3 parenthesis negative 3 cubed minus 2 negative 3 squared plus negative 3 minus 4, right? So what's that gonna be? What's gonna be our answer for such? Okay, so you can use your calculator for such, or your TI or decimals for such, right? So 2 plus 712, if you want to reset your calculator, right? We're just evaluating this particular px, our polynomial, at negative 3, right? So let's do that one in here. What's that gonna be? 3 parenthesis negative 3 cube. So by the way, this caret up is the cube on your calculators, TI. Press right. Next is what? Minus 2 times negative 3 squared. So the x squared is above the log button. Right, there we go. What's next? Plus x. Your x is negative 3. Once again, the negative is this one in here, right? The negative is at the bottom, right? Minus 4. And the minus, by the way, is the one above plus, right? Because in TI-84, it's kind of confusing which one is negative and which one is minus, right? The minus is above the plus. The negative is below in here. You get it, right? So, what did you get as an answer, guys? Okay, evaluating this one at negative 3, what did you get as an answer? Negative 106, right? Very good. That is correct. Now, what is this negative 106? That basically is the remainder already, right? So put in here, this is basically your answer already for such remainder, right? Once again, you only use the remainder theorem if you're not interested with the quotient, right? You just want the remainder. Are we good?
Would you have to put the 106? Would you have to do negative 106 over x plus 3?
That's a good question, Madeline, right? So, the question is, Mr. Deal, we said last time, if you want to get the quotient, you always need to divide this remainder by the divisor x plus 3. Do we have to do that one in here? That's a good question. The answer for that one is, just leave it on its own, right? Once again, you only divide the remainder by the divisor if you want to put it with the quotient, right? But if you're just wanting the remainder, then you already got your answer. Are we good? Questions, guys, to that one? Okay. Now, There's one more important thing about remainder theorem. Actually, it's more of like a follow-up, right, of remainder theorem, right? Let's read our factor theorem in here, okay? Chris, go ahead. When
x minus c is a factor of f of x, then f of c is
equal to
equal to
0. Got it? All right, thank you. So, basically, it's the remainder theorem, right? If you got x minus c, you make that minus what? Sign change, make it c, right? If it turned out that the function that you evaluated with turned out to be 0, that only means that that divisor is what? A factor. Once again, why? Because if the remainder is 0, then that means that divisor is a factor. Are we good? Right. Well, let's read that one and answer, I would say either 14 or 16 for such. Alright, let's read the instruction first and see how we can answer 14 or 16. Ready? Logan, go ahead.
For the following exercises, use the factor theorem to find all the real zeros for the given polynomial function and factor.
Thank you. Alright, so it says in here, use the factor theorem to find all zeros for the given polynomial function and one factor, right? So, what do you want us to try in here, Logan? 14 or 16?
14.
Let's try number 14. Thank you. So for number 14, you are given what? So your px is equal to what? 2x cubed minus 9x squared plus 13x minus 6. Get it? Okay. You are given a factor x minus 1, which means that in this case, your c is equal to what? What you gonna do with that x minus 1? Positive 1. Very good. Okay, right? So that's x minus 1. You sign change that 1. Your c is equal to 1. And basically, what you're gonna do with this? Very good, right? Evaluate your p at 1. Okay, so very good. That is correct. So let's do that one in here. So evaluate this whole thing. This whole polynomial at 1, right? So that's gonna be what? 2, 1 cubed minus 9, 1 squared plus 13 times 1 minus 6, okay? And let's see what your p of 1 is, guys. Get it? Okay, let's do that one. Use your calculators for such. 2 parenthesis 1. The caret, once again, is your exponent, right? Press right, okay? Do not forget to press right. And then minus, the operation minus, not negative. 9 parenthesis 1. You close the parenthesis first before you square it. Okay, so, and then what's next? 13 times 1, go, minus 6. Are we good? Right? And then see what the answer is. What answer did you get? Magnolia? Reagan? 0. Very good, right? So again, in here, it shows that p of 1 is equal to 0. That only means that what? X minus 1 is a factor. Are we good, guys? Get it? Well, if x minus 1 is a factor and your polynomial is degree what? What degree is your polynomial? Civilized. 3. Very good, Candy. That's degree 3. So how many more factors or how many more roots are we looking for? Well, this is degree 3, right? You already have 1 identified, right? Then how many more do you need? 2 more. Get it? Get it, guys? Okay. So once again, this is degree 3 polynomial. X minus 1 is confirmed to be a factor, right? So by linear factorization theorem and fundamental theorem of algebra, we're just looking for what? 2 more real roots. Are we good? Right? And what's the best way to get the real roots according to linear factorization theorem? Desmos graph it, right? Okay. According to our Desmos graph, it says the zeros will be the factors, right? Well, at least the real factors. Well, let's go ahead and graph it, guys. Ready? Okay. So can I erase this one, guys, now? Okay. So let me just erase this one really quick. And just plug in the values here, right? We're looking for number 14. 2x cubed minus 9x squared, there we go, plus 13x minus 6. Get it? Okay. Looking in here, so we know this is degree 3, right? We get? One of the factors is what? X minus 1, right? Okay. We're looking for 2 more factors. What do you think are those other 2 factors? The other 2 zeros, right? Very good. Get it, right? And by linear factorization theorem, right? What are the other 2 roots? So again, one of the roots is this, x minus 1, which we just have confirmed a while ago, right? What else are the factors? This one in here, right? So that's what? If it's 2, this will be what? X plus 2 or x minus 2? X minus 2. There you go, right? Again, your linear factorization theorem tells us whatever the 0 or x-intercept is, sign change that, add to x, that will be your factor. We good? Well, what's the other one? What's that going to be in fraction form? 3/2. Very good. Thank you, Bryce. That's correct. X minus 3/2, right? Actually, this one, typically in this case, you can move this one in front. That's what we call bottoms up, and write this one as what? 2x minus 3. And we did, right? So we have identified all the 3 zeros of such, right? X minus 1, 2x minus 3, and x minus 2. Get it, guys? Questions?